Okay, we have section 9.5, problem number 40. They ask us to find the vertex of each parabola. Now, when it's in this form, they've given us all the information. And that is because in this form, the parabola, a generic parabola looks like this. Like this, all right? So when it's in this form right here with the x all in this nice, neat little completed square package like this, then my vertex here is going to be HK. So if we look at it in this form, my H, let's see I have a subtraction just like that, so my H is 3. And my K, there's a plus right there, so my K is 7. So this is my vertex right here of this parabola. Let's look at problem number. Okay, now this section right here, because we didn't do horizontal parabolas, they mixed in 9-6 with this, so we don't know how to do 41 and 42. Those are a little different. And problem number 43, we're going to do, just because there's not very many for us to look at. So we have y equals 2, x minus 2 squared minus 3. Right, okay, so it's in this form, right, of y equals a x minus h squared plus k. The vertex here is going to be hk. Okay, that's the little point of inception that the parabola grows from. And a right here tells us a lot about the parabola too. If a is positive, it opens up. If a is negative, it opens down. Now, if a is the absolute value of a is a big number like 3 or 10 or negative 17, okay, whatever number right there, if it's bigger than 1, the absolute value of it is bigger than 1, then it's going to be skinnier. And if it's smaller than 1, between 0 and 1, then it's going to be a wider parabola than our normal graph. So this right here, this 2 tells me that it's going to be skinnier than normal, and it's opening up because this is positive. The vertex is 2, negative 3. All right, it has to be in this form. See, so those match, and so the 2 is the H, but those don't match. So if I was going to make this a plus, then that's a negative 3. So there's my negative 3 right there. My vertex is 2, negative 3. They ask us to graph it, give the vertex, the axis of symmetry, and the domain and range. So the vertex is 2, negative 3. I know that it's opening up and it's skinny, so it's going to look something like this. Maybe even skinnier if you want. The axis of symmetry always is a vertical line for these vertical parabolas, and it goes right through. Now, vertical lines say x equals something. The equation of that is x equals something. Well, x is going to equal whatever the x value is on my vertex. So x equals 2 is my axis of symmetry, and the domain is whatever x can be. Domain is whatever x can be. There's no restriction on this. Now, I know that it's a skinny parabola, but those arrows on it show that it can just keep going forever and ever. Also, remember, we only have restrictions on our domain on 2 things, and that is x inside of a square root and x in our denominator. And that's not either of these cases. So my domain is going to be from negative infinity to infinity. My range, however, is whatever y can be, and you can see that it just starts right here. So it's going to start, and we're going to include that y value, which is negative 3, and then it goes up from there. So negative 3 to infinity. That's all of my information, and we get it all just from that little formula thing right there. All right, now I would suggest that you practice a lot of these. There's not very many on this particular page to practice. On the very next page where it says mixed review, page 566, look at problem number 67 and make sure that you can match up the graphs to all of those. That's important, but because they've given us a mixed review and we're not doing 9-6, we don't get enough practice right here in the problems here. Okay, problem number 48 says the height and feet of a projectile, blah, blah, blah. Find the number of seconds required for the projectile to reach maximum height. That, again, is a problem from section 9.6. So let's move on to problem number 50. And this is in 9.7. Problem number 50 gives us this inequality. X minus 4 2x plus 3 is greater than 0. All right, so with these right here, these are bits and pieces of a parabola. And if we multiply this out, I would have 2x squared at the front. If I had 2x squared at the front of a parabola, I know that that parabola is opening up and that it's skinny. Now, I don't know, looking at this, what my vertex is, because it's not in that nice little form that we have. But I can say, if I was going to set this equal to 0, I could see what my boundary points are. So x equals 4 is a boundary point, and then x equals -3/2 is another boundary point. Okay, now those also are the zeros. Okay, so if I imagine my parabola opening up and being skinny, it passes through my x-axis just like this, through these zeros. This is where my y equals 0, right here. At x equals -3/2 and at x equals 4, I get them crossing my x-axis. So if we kind of imagine this as being the x's, here's my -3/2 and here's my 4. Where is this greater than 0? We should get this and this. But let's test our intervals. All right, I'm just going to test 0 right here. Test x equals 0. And if I put it in here, I get -4. 0 minus 4 is -4. And 0 plus 3 is +3. Is -12 greater than 0? False. No, so this section is false. Now that was what we had suggested would probably be the case, because we're looking for greater than 0. We're looking for right here where it was above the 0. This is our 0, our y equals 0 spot. So that's going to be a true, false, true. You can check these points too if you wanted. You could pick a 5. Let's put 5 in there and just double check. So if we put 5 in here, we get 5 minus 4 is 1. And then we get 5 in here, we have 10 plus 3 is 13. So is 13 greater than 0? Yeah, it is. So that's true there as well. So do we include our zeros? No, it's not also equal to. So we just have this with a soft parenthesis because we're not including those boundary points of -3/2 and 4. The interval notation is -infinity to -3/2. We also are including from 4 to infinity, and so we're going to use that union symbol. Those two intervals. Okay, that's problem number 50. Let's look at problem number 52. Problem number 52 is different in that it's not a parabola. This is an x to the third. If I multiplied all of this out, I'd have x to the third. So, you know, if you multiply this, I'd get an x squared, and then multiply it by that, I'd get an x to the third. So we don't really know what those graphs look like necessarily, but they are probably going to cross my x-axis. If I think about this as all of my x's, it's going to cross that 3 times. And here are the places: -2, 3, and -5. So x equals -2, x equals 3, and x equals -5 are my zeros. This is where it's equal to 0. So I have x equals -5, x equals -2, and x equals 3. I am going to have to do a test point. I like to choose 0 just because computationally it's really easy, but you could choose any interval. So if I put in 0 here, then I get a 2 in this first one. If I put in 0, I get 0 minus 3. That's -3. 0 plus 5 is 5. And is that less than or equal to 0? I have 2 times -3 is -6. -6 times 5 is -30. Is -30 less than 0? Yes, it is. So this is going to be true. So we should have every other. We should have false, true, false, true. The reason why we have every other, and we know that it's every other, is because we have 3 x to the third and 3 boundaries. If you had less boundary points than the power that it was, you'd know something was a little funky about that graph. But you can check all the intervals if you want to. But what we need to know is that it does include our 0. Now these values right here are where they are equal to 0. They are also our boundary where we go between true and false. So we're going to include those boundary points. There's a true section and there's a true section. So that says from -infinity to -5, including the -5, and from -2 to 3, including those endpoints. That's going to be your final answer there for problem number 52. Oops. Okay, gosh, I guess that's it. That's it for chapter 9. Remember to practice those, though. Remember to practice those parabolas more than what practice they gave you. Look for other problems to do either back in 9.5 or else the ones in the chapter test.